Okay, so I just want to kind of navigate Blackboard a little bit, just to kind of get a better comfort level with that. So when you go in, you land on the welcome page. The units of study are over on the left side, but that should be pretty consistent for each course. And we're in Unit 1. So if you look at your schedule, we're Unit 1, Day 3 right now. So scrolling down to Day 3, this is where you should have gotten the notes over the weekend. Our essential question: when are manipulative techniques necessary? Manipulation techniques, excuse me, necessary. So there's the notes video. I always tape what we do here at the beginning of class and put that into the class discussion in case you want to view that. We're going to do our second flip book today. And then this is going to be your homework tonight. And so we'll do our flip book, we'll do our topic questions, and then you'll have some con to start on. Okay? So any questions about that? Okay. So a couple people are like, oh, I forgot to take notes over the weekend. And you know, it's a process. We'll get you there. At the beginning of the year, it's kind of you know, we're just getting used to the schedule. So you know, any one day is not a huge deal. Today, what we're going to be focusing on, the takeaways from the notes, is we know, and we can tell by our flow chart, and I have the flow chart up on the wall there. It's also in your note packet. We know that limits are more than just function values. Okay. If we have an algebraic expression and we can plug and chug and find a finite value, that's awesome. You know, there's your limit. But it's more than that. We gotta accommodate for things like, well, when I have a hole, my limit is down here, it's not up there. Or if I have an asymptote, then I could be doing different things on either side of the asymptote. So we know that it's just more than just function values. Limits exist when function values do not, like the holes. Rewriting a limit in equivalent form is a supercritical skill. Okay, and that's where we get the indeterminate forms that need to be re-expressed. So from the notes, and we'll kind of preview, or we'll kind of review it here, coming over to the flow chart. Okay, that was our plug and chug, right? Direct substitution gave us a real number. And then we had our approximation table model. That was last week. Now we're talking about this right here. We're talking about when I put in values and I have this rational expression, right? Rational expression. I get 0 over 0. We call that indeterminate. Okay, and the reason is, if you look at the value standpoint, what do you think 0 over 0 should be? 0? Any other ideas? Why do you think it's 0? Well, okay, so I got 0 on the top, right? 0 on the top, 0. They also got 0 on the bottom. What is that? Yeah, that means it's undefined. So now I've got a conundrum. Right? You say 0, you say undefined. Could anybody possibly look at 0 over 0 and think why? Like, oh, yeah.
Normal numbers when there's like a 1 over 1 or 2 over 2 equals 1.
Right? Divided by itself equals 1. Okay, and that's the problem. That there are 3 different ways to look at that rational expression. And those 3 different ways we define it. So we can't consistent. If I asked you what's 2 plus 3. So we need other techniques. Okay, basically what we need to do is we need to deal with the fact that that to re-express this so that. Okay. So these are the three techniques. Okay, you're either going to have a polynomial over a polynomial that you can factor it. Okay, and the polynomials are usually quadratic, so you can understand. Or they're binomials, but you set the factor out. Or you use your trig identity. So you get your trig flipbook out and you use those identities. We're actually going to get our trig flipbooks out so that we can focus on the identities we need to look at 2 times time again. Because that trig flipbook has got a lot of stuff. You only use about 25%. And then there's conjugates, which is probably the first time you've ever had any interaction with that term, conjugate. Conjugate basically means, maybe when you do complex numbers, high numbers, you might have talked about conjugates. But conjugates are basically like x plus 3 and x minus 3 are conjugates. They got the same first and second terms, exactly, you just have signs in the middle. And what that does is when we multiply conjugates together and FOIL that out, we end up losing our middle term. So that's what it cancels out. And that helps a lot. So those are the go-to strategies. Okay, the first thing we do, plug, get numbers, within 0 over 0, where you know we're in one of those 3 buckets. Okay? And your type of questions tonight will have you do each one of those methods once. I'll get to that in a little bit. Okay, so so going on then to number 4, factoring. Okay, so now number 4, factoring. I'm talking about that method. I'm too far away. Method E, right there. E, F, and G and flow chart. Talking about method E here. Factoring is by far the most common. Most often they're going to give you a polynomial that you can factor. Then the next one is trig. That's the next most common. Remember, and this is from the notes. So if you're kind of falling into the category of I forgot, still getting into the flow of things. We talked about an example where we canceled factors, and that creates a hole in the graph. Okay, that's what happens when you have 0 over 0, and you have 2 factors, the same factor top and bottom. That's what creates the hole in the graph. Conjugates by far, number 6, conjugates. That's E, F, G. That's option G on your flow chart. Conjugates by far are the least common method. If you get 1 per test, I'd be surprised. That's a uncommon. There we go. Uncommon there. And then just a reminder, you have your trig identity flipbook. And when can you use your trig identity flipbook? All the time, right? I'm never going to take it away. College Board will take it away. They won't let you use it. Okay, but I will never take it away. Okay, and then I mentioned this just a second ago. You're going to use each method at least once on your topic lessons. Okay, before we jump in to the activity, I see most of you have folded it, which is awesome. Here's just a random screenshot. So we did estimating. I just want you to see how I kind of process things. We did estimating, calculating and calculating limits. And you had some and it was 8 of them. So I took all 8 of them and I kind of figured out what your grade should be. If you got hundreds all the way across, obviously you got an A. If you had 4 hundreds and 4 75s, you got an AB. If you had all 75s, you got a B. If you had most hundreds and the rest were 75s, like 600s and 2 75s, I gave you an A. I tend to kind of grade a little towards the high end. If you had all A's, but you're missing the last 2, then I put an M in until you've completed those last 2 to at least until 75. Okay. So so that grade will always be an A, an AB, a B, or an M for missing. And so if you haven't completed them all, I just stuck an M in there. It's just a placeholder until you complete them all. I go back and check multiple times to make sure you're getting those done. And then in the comment section, like in this comment section, I didn't record your notes. I'm going to start doing that today. But in the comment section, if you notice, like this person had topic question A and topic question B completely done and submitted in College Board. This person is missing both. This person is missing one of them. So those are the notes. And again, that's a quick reference for you. But it also allows me to see some patterns, like, are you never doing your notes? Or are you never going into the topic question? So I can have those conversations about what it's just kind of cross training, kind of make sure you're completing the whole package of stuff so you're as ready as possible come May. Okay. Topic questions are typically 6 questions, so no more 12 question sets. Okay, they're 6 question sets. It's just that with the plug and chug and the graphing, those go real quickly. So I gave you some more than I typically do. So any questions about what the grade book kind of looks like and what the notes mean? Okay. Here is your trig flip book. These are the ones that you will be using. Okay. Either in the topic questions or in con. Okay. You're going to use those basic identities, right, for tangent and cotangent and secant and cosecant. So maybe like star those in your flip book, or highlight them, or put a box around them, or something. We'll use the Pythagorean identity a lot. Okay, sine squared plus cosine squared equals 1. That's actually the equation for a circle. X squared plus y squared equals 1. That's the unit circle. And then double angle identities. You'll use those so that you can get the 2 theta out and have it be just a theta. Okay. So put a box around those in your flip book. Most everything else, we've got the unit circle in the back of your flip book. Most everything else you can ignore. Okay, so that's why I say, put a box or a star next to it or something like that, so that you know what to ignore. We'll hang out here for a little while you note that in your flip book. Can't remember where they were off the top of my head. Basic identities are on the top of the blue page. Pythagoreans are on the first orange page. Double angles are midway through on the green page. Okay, is it okay to flip the screen? Good. All right, so when are manipulation techniques necessary? So this is getting into the notes. So you take the notes out so we can get that summary. When do we need to use methods E and F and G on the flow chart? Let me see what. So you can, when you're thinking about this, you can work your way up backwards through the flow chart, or you can look at your notes. we use methods E and F and G. We have what scenario?
Zero.
0 over 0, exactly. When we have plugged in some numbers, and you know, I think this deserves being said, right? We got to look at the limit problem and say, oh, I have a rational expression. I have a fraction, right? I have something over something, rational expression. And I just plugged in my approach to value, and I got 0 over 0. Okay. So indeterminate forms of rational expressions, 0 over 0, and infinity over infinity, which is rare, but it does happen. Okay. Go ahead and get that summary down, your notes, even if you haven't taken the notes. This will help you focus on the topic questions and what to do. Tasks. Foldables 101. So when can you use foldables? All the time. Exactly. So the purpose of this foldable then is to get, you have an example problem, and then they have you work the problem in the dashed box. So after you get done working the problem, you have 2 examples of each variety of manipulation techniques, and you can refer back to them. Okay? Is it okay to go off the screen? Good. Okay. So, oops. There we go. So we're going to skip the folding, but we're going to open up the foldable and look at the basic rules. Now you don't have to copy this down, okay? But if you look at the basic rules at the top of the first page, we did all of these rules last week, right? We can add, we can subtract, we can multiply, we can divide. We did all those things last week, right? So like if I'm taking the limit as we approach -3, the limit of function h is 3, the limit of function g looks to be 2, 3 plus 2 is 5. Okay. Couple of things I also want to talk about. Limits at infinity. Okay, limits at infinity. That's on the bottom part of that page. We're going to have a whole section about infinity. Okay, but I just really want to draw your attention to the special limits. This one, anyone remember what this looks like? Yeah, right? Right, it's right here. I've got it right up there on the wall, okay? So it's just important to know these basic shapes, okay? And which functions grow faster than others. So like e to the x grows really fast, and ln x grows, but it grows really slowly, okay? So, and so basic shapes, I have a basic shapes chart on the wall next to the limit flow chart, so we can get an idea of basic shapes of functions. Okay, so this is what sine of x over x looks like. We can find its limit as we approach 0. This, and you know, it's not hugely important, But this is what 1 minus cosine x over x looks like. It kind of looks like you took off the left-hand side and kind of, you know. So, so that is what 1 minus cosine x over x looks like. It's indeterminate at 0, and we don't know how to find it without looking at a graph yet. And it'll be a while before we can. Same with sine of x over x. As we approach 0, that's indeterminate, and we need a graph right now. Okay, to evaluate the limit. And then this one is an interesting function, and I only bring it up because its limit is e as we go to 0. In other words, as we cross over the y-axis, we're up here at about 2.7. That's the intercept. And so it's kind of an interesting one because it has to do with Euler's number, which is that about 2.7 number. Okay, so that's all I'm going to say about that. So what I would like you to do with a pod mate or a person you can work with is I want you to do 1 through 4. So for instance, if you open up to the middle, that's 1, 2, and 3. And then the next page, we see a 4. And then the last page, we see a 6. Okay, so I want you to do, then I'm going to keep this up, so I'm not going to go past the screen. Here are the answers you should be getting as you work those problems in the dash box. Okay, and that will provide you with a good resource to use. After you get done with the foldable, then go ahead and do the Unit 1, Day 3 topic questions. Okay, and then we have notes tonight and Con. We also have a quiz. So in order to qualify for a retake on the quiz, you need to be done with all of your Con. Okay, so keep that in mind. So when we take the quiz tomorrow, I look at all your Con. If all your Con is done, then if you don't do so hot on the quiz, I give you an opportunity to retake that quiz. Okay. All right. So go ahead and jump in with a partner and crank out the foldable. I'll come around and just kind of check in with you.